Hi, I'm Rob, N1NUG, and today I'm out here screwing around with a Delta Loop antenna once again. Now, I'll tell you the full story another time, but about a year ago, I released a video where I tested out a Delta Loop here in the yard, and it seemed like it worked pretty well. And I had started the process of trying to develop a Delta Loop for 40 meters and above that I could use portable for POTA or field day or something like that. Long story short, I lost the antenna. I ended up getting discouraged because of that, and I just put the project aside and got busy with other things. But now I'm finally thinking about it again about a year later. Well, I think I've come up with an idea for this antenna that's going to make it almost as easy to deploy as an end-fed half-wave and use about the same amount of space and sort of the same type of mounting arrangement that you would use for an end-fed half-wave. Now, I don't know if this is really going to work or not, but the only way to find out is to build it and try it. That's what ham radio is all about, experimentation. Now, I know you might be thinking, why don't I model this in software first to see what it's going to look like electrically? And the reason for that is because I just spent 60 hours this week looking at engineering software, and that's the last thing I want to look at on a Saturday with the sun out. So it may be a waste of time, but I'm going to build this thing up and try it out without any kind of simulation ahead of time. The formula for calculating the length of wire you need for a Delta Loop is 1005 divided by the frequency in megahertz. So if I do the math, 1005 divided by 7, roughly, I'm getting about 143 feet of wire. Now, I realize you probably can't see it, but I've got 145 feet of wire, so I have a couple of extra feet, laid out in a rough triangle here behind me on the driveway. Let me show you what I've got laid out here so far, and then we'll take the build from there. I used the trunk latch of my car to kind of tie these two wires off. This is eventually going to be the feed point where I'm going to hook up a 4-to-1 balun. And then if I turn around, now you can probably see the wires kind of diverging in a triangular fashion off that way. The reason I've got this tape measure here is just so I could see how long it is from the feed point to the base of my antenna mast, which is laying over here. So this wire that follows the path of this tape measure is going to be parallel to the ground when this thing is erected. And then here at the bottom of my 31-foot pole, maybe up about a foot or a foot and a half or so, is where I'm going to mount the wire and then have it go vertically up the pole to form one of the legs of the triangle. And then up here at the top, again, maybe a foot or a foot and a half or so below the tip of the antenna mast, it's going to turn again and go back off to the feed point, forming the hypotenuse of the triangle. Now, I didn't have the camera on for this part, but the first thing I did was to find the exact center of the wires. So the way that I did that was I had them tied off to the trunk latch like you saw, and then I just walked this out the driveway until both legs were even, and then I marked it with a piece of tape. And then what I did is I measured from there 14 feet that way to the tip of my antenna mast and 14 feet that way to the bottom, which makes a 28-foot leg of the triangle. Now, this pole is 31 feet long, so that gives me a little bit of leeway to keep the bottom leg of the antenna off the ground and the point where it turns and goes down the hypotenuse down from the tip of the antenna a little bit. So then I pulled out the big tape measure here, and I figured out that the length of the leg of the antenna that's going to be parallel to the ground once this is stood up is about 58 feet. So it's actually a little bit shorter than what you would need for a 40-meter end-fed half-wave, which is normally around 64 or 65 feet. From where I found the center of the vertical leg of the antenna, where I measured out the 14 feet on either side, I marked it with some white tape. So what I want to do now is make some kind of holding bracket so that I can run the wire vertically up the mast and then turn it the angle I need to go back to the feed point, but also make sure that when I put this thing together after it's been disassembled, that it stays at this point where the tape is, so that we always have sort of this 28-foot length of the leg vertical to the mast. Now, if you're thinking about building an antenna like this and you have a 3D printer, you could probably whip up some kind of bracket or something that would work well up there at the top of the mast. I don't have a 3D printer, and even if I did, like I said before, I don't really want to look at any more engineering software right now. So what I do have is this cheap 99-cent cutting board that I got from Walmart. Well, with inflation, these are probably $2 now, but you get the point. Now, somebody once told me what kind of plastic this is. I can't exactly remember now off the top of my head. I wouldn't run a kilowatt through an antenna that used supports made out of this material, but it works well for me for 100-watt antennas. I've got a scrap piece of the cutting board material here, and I've got a 2¼ inch diameter hole saw on the end of my drill here. So here's the plan. I'm going to slip this over the top, and you can see that it travels down and kind of hits where this first joint is. So what I think I'll do is drill the hole out in this one size bigger so that it can slide over this sort of second thicker section, and then it'll get to a point right about here where I've measured out, and it should stop and kind of hold itself there. I'm also going to deburr this since it came out a little bit rougher than I thought it might with the hole saw. And then I'm going to drill a couple of holes in the periphery here so that I can run my wire through it. A lot of the things I do on this channel are somewhat questionable and a little unorthodox, and this next part's going to be no exception. Now that I've got my support piece fabricated up, I'm going to slide it over one end of the wire. And then right behind it, I'm going to slide a washer that is a little bit bigger than the hole that I drilled in there. And then I'm going to slide this ring terminal over, and you'll see why in a minute. Now I'll just slide these down to the wire until I'm over near the mast. So I'm at the point of the wire where I marked out with the white tape. This is the top of the mast where the wire is going to turn and form the hypotenuse of the triangle. So what I'm going to do is roughly position this, kind of like this, and then I'm just going to crimp this ring terminal onto the wire. And what this is going to do is hold this in place so that this spacer can slide down the wire this way if I want to remove it, but it won't be able to go any further than this on the other side of the wire. So here's the finished product, more or less. I've got the spacer slipped over the mast as far as it'll go, and the wire is through, and as you can see, the ring terminal is holding this from pulling through any further. But I can disassemble this and slip the spacer off the other end of the wire if I want to remove it. Now I did order some wire clamps that would make this a little bit cleaner, but those were back ordered. They're not here yet, so I'll probably cut this ring terminal off and replace it with the clamp later on. Down here at the bottom of the mast, we could make a very similar type of standoff like I did on the top with the cutting board material. However, I don't have tools to cut that cleanly set up and ready to go. So I think for now, for temporary use, I'm going to just use the same type of method that I'm using to guy the mast. A hose clamp with some pieces of paracord clamped to it. Now I'm not going to lie, this is probably going to end up becoming a permanent temporary solution, only because once I'm done with this, I'll probably move on to some other project and forget about making that second standoff, since I have a feeling that this will work just fine. Now you may be wondering why I'm using what is essentially a breaker bar, and that's because I can't find the little screwdriver version for my 1/4 inch drive sockets. I'm not going to do this until I actually set this up, but what I'm going to do is just thread the wire through one of these loops, whichever one happens to be on the side of the mast where it's oriented, and then send it back to the feed point, and it should hold it. I've got the mast all guyed off and ready to go. We'll get the antenna on here in a minute. Before I do that, I just want to show you, I've got these little tensioners that I made out of that same cutting board material, and they work pretty well. They're just roughly cut rectangles with 3 holes in them, and then I run the guy ropes through the holes, just like you'd find on maybe a cheap tent, and then I can slide these things up and down to put tension or remove tension from the guy ropes. To get the wire set up now, I'm going to run what I'll call the longer free end through the bottom tie down here. Now I'll feed this wire through the loop until I find the standoff that's going to go on top of the mast, and I'll run this free end out to where my feed point is going to be. I'm probably too far back with the camera for you to see this, but the piece of tape that I left on here that marks the bottom of the antenna where the wire is going to turn and go parallel to the ground is here now. So I'm just going to kind of keep track of that, but I'm going to still work this wire through until I find my top insulator. Now we've pulled it through to the point where we've got the top bracket. So now I'll grab my standoff and drop it over the top of the mast, which I have the first section extended already. So I'll start extending that out, get that seated down where it kind of fits. And now I'm going to extend the rest of the mast up. Now, as I do this, I'm going to make sure that the part of the wire that's supposed to be vertical goes up and pulls back so that white mark is at my loop on the bottom. Okay, that looks really good. Let me show you. So that white mark that's at the bottom is right at the loop where I expected it to be. And you can see the wire is vertical. It's a little bit away from the pole, and that's because up at the top of the pole we've got a little bit of a bend, but that's to be expected. So now what I'm going to do is walk both of the free ends over to my feed point, which is going to be over there by that side door of the house. And we'll see if we can get this antenna connected up and see if it actually works. Here's what I've got for the feed point. This is an LDG 4-to-1 balun. I put some crimp terminals on the ends of the wires and screwed them down to the terminals here. I've obviously got this supported on some paracord to this pole right here. And I've got some RG8X coax about 30 feet or so going off over to the garage so we can hook this up to a radio in a minute. Now, as is usually the case with projects like this, it came out kind of the way that I pictured in my mind, but not exactly. And the reason for that is twofold. First is the terrain in my yard, which I'll show you in a minute, and the fact that I forgot about wire sag, which I'll also show you in a minute. I always forget about the wire sag. Long story short, this bottom wire is touching the ground. But we're going to try this antenna out in its current configuration anyway. Here's a better idea of how everything is laid out. The feed point and balun are here, obviously, and the wire goes off to the pole over there, which is uphill a little bit. I should have thought about that a little bit more before I set this antenna up, because as a result of it going uphill and the fact that the wire is sagging, this bottom wire is actually touching the ground. That's why that yellow bucket is over there. It's an attempt to keep the bottom wire off the ground as much as I can. Now, in the future, what I think I'll do is set this up on flat ground and also use those garden stakes on the bottom, those plastic ones, to keep that bottom wire off the ground and somewhat level. So let's walk over to the other side, and you can see this bottom wire is sagging. It's on the ground. I've got it propped up on this old bucket here for now, just to keep part of it off the ground. I don't know if that's really going to do much or not, but it's pretty much running on the ground right here where we're going uphill, and then we get to the support pole over here. Now, if we take a look at the mast, you can see now that both wires are on it and fully tensioned, or, well, maybe not fully tensioned, but tensioned. There's quite a bit of bend in the mast right now. So I think this would do better with a stiffer mast, like the Spider Beam's 40-foot mast would probably be a better choice. But we're going to work with what we've got today. I've got the Nano VNA sweeping between 3 and 30 megahertz. And based on the results that I'm seeing, I think I screwed up and cut this wire way too long. If we move the marker over to the first null, you can see we're at about 5.7 megahertz at that null with an SWR of about 1.2. If I move up band, you can see that the second null is right around 11.3 megahertz or so with an SWR of about 1.7. I won't bother going up to any of the other bands, but suffice it to say, the resonant point of where I expected it to be is several megahertz lower at each null than I thought it would be, which indicates that the wire is too long. I'm going to trim some wire back. I'm going to take off the same amount on each side and just move the feed point closer to the pole until we get the antenna down into the 40-meter band where I expect it to be. And then we should get nulls in the 20-meter band, hopefully 15 and 10, and maybe even 6. I guess we'll see. Just to show you how I'm trimming this thing, I'm measuring out 2.5 feet, and then I'm cutting each wire. So I'm taking 5 feet total wire off the antenna at each go. Now, each time I trim this, it seems to raise the resonant frequency a few hundred kilohertz. So we're moving in the right direction. The reason I'm not taking more wire off is because I just don't want to take too much and then have to add it back on. I think I've got the antenna tuned up pretty much where I want it, despite having some trouble with this adapter, which fell apart on me and kind of misled some of my readings for a little while. Anyway, you can see I've switched over to a different adapter, and we've got a pretty good looking curve here. Now, if I move the marker down to this first null, Hopefully you can see in the screen there that we are looking at an SWR of about 1.3 at 7.05 megahertz. Now I'm primarily a voice operator, and this is the CW part of the band where it's best, but I actually prefer my antennas to be better sort of at the lower part of the band. They're a little bit easier to tune if you need to. But you can see if I move up to 7.3 megahertz, the SWR is still 1.741, so that's pretty good. Now if we move up to 20 meters, let's see what we have here. You can see the antenna looks best right about at 14.34 megahertz, so kind of at the top of the 20 meter band. But again, if we move down to 14.07, the SWR is still pretty good, 1.6, so I think that's going to work fine. Right here you can see at 15 meters, we've got a null right around 21.9, and again, if I back this up to sort of the voice portion of 20 meters, we're still looking at 1.5 SWR, so pretty usable. And then further up, you can see right around 28.9, we've got a null of 1.3, but again, if I back this up to the normal voice part of 10 meters, 28.38, we're looking at 1.5. So I think this is going to work out just fine. Now, I'm only sweeping between 3 and 30 megahertz, but I'm hoping 6 meters looks good too. I'm not going to set that up on the Nano VNA right now. I'm just going to set the radio up and we'll give it a try and see what it looks like. As you saw in the Nano VNA, the antenna's working pretty well now. I probably took 20 feet of wire off of this thing. When I first measured this out, it was over a month ago, even before I went on vacation. So I'm not sure what I was thinking, but I must have measured out the wrong amount of wire. When we're all done with the video, I'm going to take this down and we'll measure it before I wind it up and put it away. One side benefit of having taken so much wire off is that this bottom wire that was pretty much on the ground before is now hovering just off the ground. It's a little bit still touching up on the hill there, but that's just because of the topography. Once I set this up on flat ground, this should be pretty much off the ground, at least by a few inches. So it's a nice evening, so I figured I'd sit out here and test the antenna out with the radio. We'll tune around and see what we can hear. Maybe we'll even make a couple of contacts. Let's see what happens.
Romeo India Alpha, contest.
November 1, November Uniform Golf.
November 1, November
In a few
Uniform
minutes.
Golf, 5 and 9, 328.
QSL, you are 59001.
Thank you, India Uniform 8, Romeo India Alpha, contest. Echo India 7, Mike, contest.
November 1, November Uniform Golf.
QSL, November 1, November Uniform Golf, 592355, Europe 115.
November 1, November Uniform Golf.
November 1, November Uniform Golf, I have you 59 into my park, Charlie Alpha 0010 QSL.
QSL, you are 57 in Connecticut. Thanks for the activation.
Thank you for hunting. It's a good day to you, QRZ. This is Kilo Oscar 4 Sierra Adam Bravo, parks on the air, QRZ.
November 1, November Uniform Golf.
November 1, November Uniform Golf, I have you as a 5 and 7, 57 into US 10406. Alpha Delta 4, Tango Mike, QRZ.
November 1, November Uniform Golf.
November 1, November Uniform Golf, have you about a 5-4. Rob, how you doing? N1 NUG, this is, you're nice, you're about a 5-7 into US 7528 on the airline trail. How you doing this morning?
I was out on the motorcycle one day, and I was out in Chaplin, and I happened to see the trail. I had my stuff with me, so I figured I'd activate it.
Yeah, if you go in the Goodwin Forest, you can pick up the airline trail, and then I believe you can make it to Natchog by riding. You don't have a bicycle. You can ride it up, and so I get 2 parks plus the trail on both those parks.
November 1, November Uniform Golf.
November 1, November Uniform Golf, I've got you 59 US 8199 South Dakota.
QSL, you are 55 Connecticut. Thanks for the activation.
All right, 73, thanks for hunting. This is Whiskey India 0 Oscar, QRZ.
Now that the antenna is tested and we know it works, it's time to pack it up and see how difficult that's going to be since it's time to mow the lawn. Actually, one last thing that I need to do now that the antenna is kind of all set dimensionally is to crimp on a couple of new lugs on the ends of my wire here. I haven't done that yet. I ended up cutting off those original ones I put on and haven't put new ones on yet, but I'll do that after this is packed up. Now that the wire is disconnected from the balun, I'm gonna run the bottom wire here through this loop and kind of pull it out of the way so that things don't get tangled up when I lower the mast poles. So the bottom wire is out of the way and kind of off at a different angle than the top wire. So what I'll do now is start bringing the mast down slowly, and I'll keep an eye on that top wire and make sure it doesn't start to get tangled on anything. Now that this is getting low, the wires are starting to twist together, so I'm gonna keep one hand on the bottom wire and keep it pulled away. So now we're at the disc. I'll slide this top pole in, but I'm not gonna let go of it just yet. One other thing I need to change with this design is the fact that I had to take my ring off of here. So now if I let go of this, it's gonna fall straight through. So that's another thing that I need to kind of figure out as far as this design goes. So I'm just gonna hang on to that so it doesn't fall through for now. I'm gonna move my disc up and take it off of here. And then I'm just gonna extend this back up for now. And then I gotta go grab my ring and put it back on the end so it doesn't fall through when this is packed up completely. Now I'll grab the bottom leg of the antenna wire that I kind of drug over here so it wouldn't get tangled. And I'm gonna wind everything up on this cheap 99-cent Home Depot extension cord winder. I bought a 4-pack of these a while back and they seem to work good for these antennas that I make out of the 14 gauge THHN wire. I'm not gonna make you sit through watching me wind this up. So I'll cut back in when this is all done so you can see how much wire is on here. So here's what it looks like all wound up, including the disc, which is now sort of permanently attached to the wire. This isn't gonna be your go-to antenna for backpacking, I'm sure of that, but it should work well for those parks where you can access them with a car. I just remembered we were gonna measure this to see what its final length was. So I'm actually gonna unwind this from here. I'll get the big measuring tape out and we'll check it out and see how long it is. I've got the wire tied off to the Suburban and running across the driveway, and then it's doubled up around this spike and runs back. So what I'm measuring here is actually 64 feet, one leg, so if we double that, 128. So my initial thought that I had cut this wire somewhere around 145 feet was correct, since I took about 20 feet off when I was tuning it. So what I think I forgot about when I was figuring out the length of this wire was the velocity factor. When you factor that in, it now makes sense that the antenna wire should be a little bit shorter than what the initial calculation was. Either way, I think we've got a usable antenna. In case I wasn't clear in the video, I'll just give you a quick look at everything that I used for this project. Over here, I've got a 3.5 foot long piece of rebar that I used to support my 4-foot military canopy pole. That was in turn supporting my LDG 4-to-1 balun, and of course a bit of paracord to kind of hold everything up and kind of take up the mechanical slack in the wire as needed. Over here is my 31-foot jacklight pole, and you can see I made up a custom guying system with paracord and clips and that kind of a thing to hold this thing upright, so I don't need a tree or something to support it in. Up here, I used 3 of these large tent stakes or landscaping spikes to support the guy wires on the jacklight pole. This, of course, is the Delta Loop antenna wire itself that we cut and tuned in this video, and also the little disc that I used for supporting this on top of the jacklight pole. And then, of course, I also had 31 feet of RG8X coax, and then other various bits and bobs like the Nano VNA, the FT891, my Bio-NO battery, all the normal stuff that you might use to tune and test an antenna. All those clips that you just saw were recorded over the last 20 hours or so. And as you saw, we were making some pretty decent contacts. However, signals did seem a little bit lower than I'd normally expect, but I think that has more to do with the fact that there's sort of a medium level geomagnetic storm going on right now than anything wrong with this antenna. Now really what I'd like to do is set up a side-by-side comparison between the loop and a standard end-fed half-wave cut for 40 meters. But before I do that, I think what I want to do is take this out on a POTA activation or 2 or 3 and see if I notice anything different using this antenna than I would over my typical end-fed half-wave. And then once I have that under my belt, maybe we can set up that comparison and see the antennas side by side. I don't think I had pointed it out earlier in the video, but you probably already noticed the wire that I used for this antenna was 14 gauge THHN wire. and that's because I already had it laying around and ready to go. And the antenna worked fine, but I think if you're going to build one like this, I'd recommend using a lighter wire, maybe 22 gauge silicone or polystealth, something like that, where you could put a little more tension and get that bottom leg off the ground. I'd also recommend maybe a different mast than what I'm using, which is the 31-foot jacklight pole. Probably something like the Spider Beam's 40-foot pole that's a little bit taller and a little bit stiffer would get that bottom leg off the ground and probably improve the performance of this antenna. That's also something I'd like to try once I can get my hands on one of those Spider Beam's masts or something similar. But overall, I think this antenna is working and performing about as well as I'd expect. But the real question that I want to answer here is whether or not there's any advantages to using a delta loop over an end-fed half-wave for POTA. And really the only way to know, like I alluded to a few minutes ago, is to take this thing out in the field and try it. So I think that's what we're going to do next. So stay tuned for more videos on this antenna. I hope you enjoyed this one. Thanks for watching, and 7-3.